Hi, everyone. We're looking at our next topic with our circles, which is to look at the different chord properties that go on and what they do to some of our arcs. So one of the first properties we're looking at says in a circle, or possibly two congruent separate circles, two minor arcs will be congruent if their corresponding chords are congruent. So if you have two matching chords in a circle or in congruent circles, then they create matching arcs. So like the statement says, if arc AB is congruent to arc CD, or they are congruent if, again, they're matching arcs, so they're matching chords, sorry. That means chord AB, segment AB, would have to be congruent to segment CD. Those two pieces would have to be congruent, hence the one dash means one, in order to cut out matching arcs of the circle. And again, those two chords are congruent, but they might be in two separate circles, which would mean their arcs would be in two separate circles. Let's take a look at our next property. So now, if a chord is perpendicular, so we're going back to perpendicular, is a perpendicular bisector. So again, bisector cut in half, perpendicular at a right angle. So if one chord is a perpendicular bisector of another, then the first chord must then be a diameter. So when we're looking at our pictures, I have one chord going all the way across, possibly all the way across on my circle. A second chord, segment TR, it is being cut into matching pieces, and I do have that right angle going on, so that will force segment SQ to be a diameter of my circle. That's what that theorem is saying. But again, I have to have the chord being cut into two congruent pieces and the right angle. I have to have both, or that one long chord is not a diameter. So very much like it says, if QS is a perpendicular bisector of segment TR, then segment QS is a diameter of the circle. I have to have those two things. Our third property, now that we know we have a diameter, says if the diameter of the circle is a perpendicular bisector, then the diameter bisects, sorry, that's not a highlighter, then the diameter bisects the chord and then the arc. So if I know the diameter, then I have to have that center. If that chord is a perpendicular, if the diameter is perpendicular, about that to 90 degrees, then it cuts that chord into matching pieces, and it would also cut matching arcs. So the chord would have matching pieces, and the arc would have two matching pieces. And so like it says, if we fill this in based off of our picture, if segment EG is a diameter and segment EG is perpendicular to segment DF, then segment HD is congruent to segment HF. And here's where we have our arcs. Arc GD will be congruent to arc GF. Again, I get congruent pieces of a segment and congruent pieces of my circle. Chords cut in half and the arc is cut in half. Our last one, last property. In a circle, again, or congruent circles, two chords will be congruent if they are equal distance or equidistant from the center. So looking at this picture, from in there, just going to make it a little bit bigger. We need to find the length of segment EF. So that is from center to chord. Well, again, my chords are the same, so then center to each chord has to be the same. So that 3x would have to equal 7x minus 8. And I need to solve this out. So let's solve this equation. I'm going to subtract that sorry, not the 3x. I'm going to subtract my 7x from both sides. So I have a negative 4x is equal to a negative 8. Divide both sides by that negative 4. And my x is a positive 2. Now remember, that's not my final answer. It said find the length of segment EF, which means plug that back in. So EF was the 3 times x length. So EF was equal to 3 times x. Yes, just verify my equation. So then if my x is a 2, I'm looking at then 3 times 2. So therefore EF has to equal 6. Now it's solved. So again, just be careful, read those questions again, make sure that we know what we're looking for. All right, example 2, in circle P, the radius is 13. So there's a big part of information there. Radius is 13. It also tells us that R2S is 24. RS is one long chord. Find the different lengths involved here. All right, so first thing I know, I have a 90-degree angle here, which means that chord is being cut in half by that radius right now. So again, we could easily extend this radius all the way out to make that diameter, which fits our property. Remember, the radius is part of a diameter. So if I have that perpendicular and I know it's a diameter, that 24 is being cut in half. Because these two pieces have to equal each other, which means they're each going to have to be a 12. Again, 24 divided by 2 gives me 12 for each side. So now I know RT. Now I need to find PT. So let me erase the other piece of my diameter here. I need to find segment PT. That is this little bitty section right there. I also need to know the other side. So I want the 2 pieces of my radius. So this is where the 13 is going to come in. Now, when we are dealing with these chords and your radius or a diameter, because of that 90 degrees, you might have right triangles going on. And so let's just add that into the property that we saw, which was this third property dealing with the diameter. Whoops, writing with a highlighter, fix that. So that we don't forget, let's add that in. We might use right triangles or might need a right triangle, which means Pythagorean theorem might happen. We might have a special right triangle going on. We might even need to use sine, cosine, or tangent. But it's always a possibility if I'm creating a right triangle. So let's take a look then at our pictures. I'm going to erase my 12s for a minute and my congruent symbols. Now, we already know the radius is 13. So no matter where this radius segment gets drawn, no matter where I draw it, it's 13 wherever I want to put it. So let's say we connect it to the ends of this chord. So now I have in fact created a right triangle. We know that the other side, T to S, was 12. So let's treat this missing piece. I'm going to redraw this triangle just a little bit bigger to work with. So if this is in fact a right triangle, let's get our 90 degrees here. We had P, T, and S. We know P to S was 13. I know T to S was 12. I need this missing length. Let's call that my A side. So we had a formula that said A equals the square root of C squared, which is 13, minus b squared, which is 12, so 12 squared. So when we plug that in, my a then is a 5. So now I know the missing length from P to T. So there is my 5. Okay, so again, all the way across, P to Q was supposed to be 13. So 13 minus the 5 we just found, meaning my leftover is an 8. So now I've got all of my pieces. Let's fill in the other parts that we need. So P to T was 5 that we found with our triangle. T to Q was 8 using my radius total. Let's try another one. All right, in circle K, arc AB is congruent to arc CD. So this time I have congruent arcs. Which will give me congruent chords. Just remember, this could go either way. If I have one, I automatically get the other. So if my arcs are congruent, and they are, they have matching marks on them, that's going to mean my chords are the same. So I can solve that out. So that means that CD will have to equal BA. So we can solve. So 2x plus 3 will need to equal 8x. So now I can subtract that 2x from both sides. So my 3 will equal a 6x. Divide both sides by that 6. And my x is equal to 1/2 or 0.5. But again, it did not say find x. It said find AB. Plug this back in. So AB, the length of AB was 8x. So if I know my x is now 1/2, then I have 8 times 1/2. So that means that AB would have to be 8 times 1/2, or 1/2 of 8 is a 4. Now we figured out what that solve was. Let's try another. Find the value of x. This time, I don't know anything about the arcs yet, but I do know I have congruent chords. If I have congruent chords, I get congruent arcs, very much like the one we just did, but it does reverse it a little bit. Because again, congruent chords, give us congruent arcs. So that means if one arc is 116, so is the other. But notice where my angle is that we're trying to find. This time I don't want the chord. My x is an angle and it is a central angle. Central angles have the exact same measure as their intercepted arcs. So that means that my arc and my angle have to be the exact same value. So always keep in mind that previous vocabulary. All right, our last two. Find the value of x. All right, so x is a chord this time. JH and IH, those are chords. I don't know anything about them yet, so check out their arcs. Arc JH, 115. Arc IH, 115. So again, if I have congruent arcs, I get congruent chords. So very much like a previous one, congruent arcs, just looking for x, will give me congruent chords. So that means 2x plus 1 has to equal 5x minus 5. Let's solve this one out. So minus that 2x to both sides. So 1 is equal to 3x minus 5. Now we can add the 5 back. So 3x should equal 6. Divide your 3. And my x will be 6 divided by 3, which is a 2. So again, keep in mind, congruent arcs give you congruent chords, and Congruent chords means you have congruent arcs. That goes both ways. Let's try our last one. Now, visually, we have two separate circles. That does not change the property at all. My circles are congruent. That was one of the main things it said. Find the value of x. X is a chord. I do not have any information on those chords yet, so then look at their arcs. Their arcs are congruent. Each one of them has one dash each on it. So again, congruent arcs give us congruent chords. Now I know how I can set this up. So 2x plus 24, my first chord, should equal the second one of 6x. So that's what it meant by two congruent circles. So let's solve this one. I'm going to start by subtracting my 2x to both sides. So my 24 has to equal 4x. Divide both sides by your 4. And my x is equal to 6. And that, I believe, is all it said. Find x. So yes, it is done. Okay, guys, so I hope you learned a little bit about your chords and arcs properties. Please don't hesitate to reach out if you have any questions at all. Bye, guys.